to speak to us about componentizing. Yes? No, that sounds right. Your development. So I hope you all had a nice lunch. And if any of you want to grab ice creams later in the break, downstairs, one of the sponsors has brought ice creams, and apparently they're very good. So yesterday, John and I, along with Martin and Max and Vitaly, we went for a little hike up the Uetliberg. That's the right way you say it. And it was brilliant, and the weather was beautiful, and the view was amazing. So if anyone from out of town hasn't done that yet, I would really recommend it for the weekend. And John brought his dog with him, little Lilu, and she is so adorable. You have to follow him for all the photos of adorable pugs.
I didn't put her on Twitter yet, like you did, right? For your dog.
Yeah, it's a bit embarrassing. So what does John do aside from rearing adorable dogs? So he's the creator of Chartist, which if any of you have ever tried to create charts that are responsive, which I have, and realize what a complete nightmare it is, Chartist, John's library, was one of the things that he created to help solve that. And he's also written a whole book on mastering Angular 2 components. So who better is there to talk to us about components and the why behind components? Again, if we have time, we'll do a Q&A at the end. So save your questions up. I want questions this time. Or send them to me on Twitter, or hashtag them with FEC16 and I will see them. And I will be able to ask them to you. So now, over to John.
Thank you, Laura, for that wonderful introduction. Actually, my talk, Componentize Your Development, we will not look so much into code in this talk. So we will really talk about the fundamentals of components. Why are components good for our development? Why are components good for our applications? So I have a tendency that I always try to find out why things work like they do work. I'm not satisfied if I just know they work and it's good that they work because they have some good effects. I really want to know why this effect is good. So I did a bit of exploration in components and in component systems, and I kind of tried to find out why these systems are so healthy for our applications. And that's what I want to share in this presentation. So my name is Gion Kunz. Laura already introduced me. So I work for a company called Odd-Even. We are a startup. We started January last year. And I'm doing front-end development there. So before we start about components, I actually want to look I want to take you on a journey through some excursion in nature, right? So how does nature deal with systems? Because I think we can learn a lot of nature. I mean, that's for sure, nature is the best teacher, right? Is the saying. So let's look at nature first, before we start to look at components and what they do from an organizational perspective. So we can look at nature. If we start at the universe, we could also start at the multiverse or what exists, but I have no clue how that works. So let's just start with the universe. And the universe is actually a system consisting out of galaxies, right? So we have a universe. In the universe, we have galaxies. So this is already a system. So we can go further down this line and explore galaxies. And within galaxies, we're going to find solar systems, right? And then in solar systems, we're going to find planets and stars, right? So that's the components, if you like, of solar systems. And now further down the line, we have vegetation on a planet. Well, eventually, right? Earth has vegetation. Other planets, we don't know yet. Probably there is. And in vegetation, we have organisms like we are, right? We are organisms. And we as organisms, we tend to have organs, right? So these are also components of our system. And like your stomach, right, which is now full of this good food actually we had during lunchtime. So organisms are made out of cells, and then cells are made out of molecules, and molecules are made out of atoms. And this goes further down and down. We don't really know where it starts and where it stops, but what we can tell is that there is kind of a hierarchy, right? So we have a universe, we have a galaxy, we have a solar system, planets, vegetation, organisms. So it's really a hierarchy of things. So Arthur Koestler goes one step further, actually. In his book, The Ghost in the Machine, he describes a so-called holarchy. And what a holarchy is, it's actually a holistic hierarchy. So you not only have a hierarchy, but the hierarchy is also holistic. So within this hierarchy or holistic hierarchy, you have so-called holons. And these holons, the definition of a holon is, it is a part and the whole at the same time, right? So it's not just a part, but it's also a whole. So in this case here, it's actually a whole because it consists of parts. But at the same time, the holon is part of something bigger, right? So it's a part and a whole at the same time. So that's what he calls a holon. So I want to tell you a little story. And the story is actually my interpretation of the parable of the two watchmakers. So this parable is by Herbert Simon and comes from his book, The Science of the Artificial. Herbert Simon is one of the pioneers of artificial intelligence. It's like the Freud in psychology. He's like the Freud of artificial intelligence, right? So the story goes like this. There are two watchmakers. There is Hora and there is Tempus. And these two watchmakers, they produced very fine watches, right? Watches that consist of a lot of small pieces, like 1,000 pieces, around 1,000 pieces. And they produced these very nice watches. They lived in the same town, and they had both a shop, right? So they were running a shop and sold their watches, and their watches were so nice that everybody called them and ordered new watches, right? So they needed to produce a lot of watches. And at the same time, they got also some watches returned that had a defect, so they needed to repair these watches. But they actually made a lot of money with this, right? So they produced all these watches. It was running really well, their business. So after some time, however, Hora was still performing really well. So he sold a lot of watches, had all these phone calls with new orders, and he could really fulfill all these orders timely. So he didn't have an issue keeping up with that. So he really sold very well. On the other hand, Tempus, he couldn't really keep up with the deadlines. He had issues repairing watches because it took him so much time. And then suddenly, unfortunately, he went out of business. And after that, Hora was actually the only person in the town who was producing nice watches, right? So that's the story, but it doesn't really tell you why he succeeded, right? So why was he successful and Tempus was not successful? So to understand why, what we are doing is we're gonna look at the watch manufacturing process of these two watchmakers. So first, let's look at Tempus' manufacturing process. So Tempus, what he did, so this is kind of a graphical representation of what he did. He put all the little tiny pieces, all these 1,000 pieces, into the watch in one go, right? So he assembled every single piece into the watch. And as I said, these watches, they consisted of about 1,000 pieces, right? So a lot of pieces, it's a lot of work. And then the problem was, whenever he needed to answer a phone call because of new orders, and you know, answering a phone call and working on a watch, it must be quite difficult, right? So eventually the watch fell down by accident. And what happened with Tempus' approach was that the whole watch was bursting into parts, and you had like 1,000 pieces again on the floor lying around. And what you needed to do is really reassemble all these parts into a watch, which took so much time, right? Also, if there was a defect with the watch, he needed to take all the parts out, repair the part with the defect, and then reassemble the whole watch. So it's really time-consuming and not really effective. And here is what Hora did. So instead of, it's also 1,000 parts. It looks like only 4 parts on this graphic, right? But it's also 1,000 parts. But what Hora did was he assembled all these little individual parts into larger parts, right? And he constructed these parts to be stable, intermediate stable components or intermediate stable forms. So what he did was assembling 10 pieces into a component or into a stable form, and with 10 of these stable forms, he formed another higher component or a higher stable form, and finally he could just assemble a watch out of 4 or 5 components, right? And when he received the call and by accident dropped the watch, it was only disassembling into 4 pieces. Also, when he was repairing a watch, he probably already knew, oh, that's going to be in this component, so I'm going to go to this component, and it's probably this subcomponent, so I'm going to check this subcomponent, repair the part, put everything together again, and he's very, very effective, highly effective, right? So we can also see some commonalities from the artificial and nature, right? So if we put this onto, or if we draw this scale in the middle, we can say that, and this comes from Ken Wilber, also a philosophist from the US, so we can say that we can go from very fundamental to very significant, right? So one part, one little piece in this watch is very fundamental, but as you go up in these components and probably the final watch is very significant, right? So that's the terminology Ken Wilber uses in a holarchy. It's also translating to nature very well. If you think of an ant, for example, an ant is made out of atoms, so the atom is very fundamental and the ant is very significant, right? So that's a good way to think about this, the scale in this hierarchy or holarchy. So one factor why this happens, why does it happen in nature? Why does nature form these stable, intermediate stable forms? Well, the answer is probably evolution, right? Because if you think of the watch falling down to the floor, it's almost the same as a system where evolution happens, where you have constant stress on the system, right? That tries to rip the system apart or damage the system, so it needs to reform, right? Reshape. If nature would do the same like tempus, if there would be an issue or a stress of evolution, then an organism would fall apart into its individual atoms again. And I mean, you need to imagine that that's completely nonsense, right? It doesn't work out. So that's some rules of evolution. And if you follow these rules, or if you have these rules, then basically it's much nicer to build these components. And that's the conclusion as well from Herbert Simon. The conclusion is, and I really love this conclusion, it gives me goosebumps when I saw it the first time. So it means like complex systems evolve from simple systems much more rapidly when there are stable intermediate forms. And for me, that kind of, I had a kind of a light bulb when I thought about evolution. Why do we have these systems, organs, bacteria? Why is everything composed, right? But if you think of it as smaller systems that try to survive in evolution, then it starts to make sense, at least for me. All right, so that's enough excursion for nature. Now we are talking about user interfaces. And we try to translate a lot of these concepts into user interfaces. So we go back a little bit in time as well here. We want to look at one of the first user interfaces actually on Xerox Alto, 1973. So here we have this file explorer that was part of this Alto system, Xerox Alto. So if you look at this now as a web developer, you could immediately start, oh, that's a component, that's an element, that's a component, right? You are trained for this, right? So you have an eye, you see what is a component, what is an element. But if we think of it together now, you can see that this is probably a component here around the whole file explorer, but then we have a component that is representing a file panel, and in this panel we have some statistics on top, a log, and then we also have a file listing component probably. So we already have a hierarchy here, right? So the question is now, are user interfaces also holarchies? Is it a holistic system? And I think, yes, we can say it's a holistic system, right? We have a file panel on the left, and the file panel is actually part of the explorer, but it's also a whole for the parts that are living in the file panel, right? So it's in both directions. It's not only a hierarchy, it's really a holarchy. And there are interconnections between these different levels in this holarchy. So I think one big mistake we made for a long time, and we still do sometimes, is that we tend to develop user interfaces only on two levels, right? So we think of pages and UI elements, and then we try to put all these UI elements onto a page, right? Even when I see people working with components, sometimes they create only a few components, and then they assemble all this together into one single component where the template is getting really, really long, consisting of all these elements. So actually, Tempus would think this is pretty good approach, right? Putting everything into one bit or every individual piece. But Hora would completely disagree, right? So he would definitely think, hey, we need to have stable intermediate forms. So let's talk about stable intermediate forms in user interfaces. If I look at these two different systems, I think we should try to develop what's on the left side and not what's on the right side. So we should try to compose components and nest them into each other as far as possible, and then really have a holarchy building up. And not that we build something on two levels, right? So that's kind of, I try to graphically show how such a holarchy should look like. But why? Why is a user interface, why should it have these properties that we know from evolution, right? That we know from nature and from the watchmakers, right? So why should a user interface also have these properties of having stable intermediate forms? Does a user interface have an evolution? Is there an evolutionary process in a user interface, in software? Yes, there is. I mean, software is constantly exposed to stress, right? So we have new business requirements, there is some customer feedback, user feedback from user testing, we need to change our software. There is constant change, right, on software and on user interfaces. So this system needs to be resistant to this change. And that's a big reason why we are creating these components. So if you look at web project complexity, for example, this is not the traditional cost of change diagram, so it shows really only the complexity that increases over time in a project. And that's just normal, right? If you put a lot of features into something, the complexity is changing, is rising. And as the complexity rises, there is possibly also more cost for change. So if you want to introduce new features. So I would go that far and say there is no such system where you can expect to do more complex things without making the system more complex. That's just the normal way how things work, right? But what I think is complex does not necessarily mean complicated. And although if we define complex as having a lot of elements in something, then if we organize these elements in a holarchic way, in a hierarchy, in a holarchy, then they are not really complicated. They're complex, but they're not complicated. Think of an example. If you try to think of one of these levels as a system in nature, for example, and you observe the system, but you don't care about the parts of the system, how they work internally, you only care about the boundary of these parts that are in the system, then you can reason about the system very easily. You can think about the system. Yeah, the universe, there are some galaxies in the universe, they're turning, or the universe is expanding, so the space between the galaxies is increasing. And if you think about a galaxy, yeah, there are solar systems, it's kind of moving. So if you don't care about how it works down the scale, you can isolate a system, and it's really simple to argue about that. And that's the same for components. If you build components and nest them into each other, one level, one component shouldn't be really complicated to think about. The whole system is maybe complex, but thinking of individual components and their level and what they do is actually quite simple. So my conclusion here is we really need to start thinking holistically, right? It's not enough if we think in BEM only, or if we think in atomic design. Well, atomic design uses the analogy to nature as well, but I think we really need to shift our mind in a holistic approach. Everything should be nested into components, right? And what we achieve with that, with building stable intermediate forms, is that we achieve application fitness, right? So it's fit for evolution, for change. It's resistant for change. We can easily change the system. We'll also achieve some simplification because the system is probably complex, but not very complicated. And of course, we have composability. I mean, this simplicity is really a big thing, because a lot of times I see people writing huge templates of components, right? And then I ask them, yeah, why didn't you create a component from this piece and from that piece and from this piece? And then basically what they say is, yeah, you know, I don't reuse them. I don't reuse these pieces. So if I don't reuse them somewhere else, why should I make them components? And I see this thinking a lot of times. But if you think of complexity, then it makes a lot of sense to build these components. Even if you don't reuse them, you can argue about your application much more easily. Because it's simple, because it's composed, right? So do not only create components because of reusability, also because of simplicity. So now let's look at components and some of the base attributes of components. So I'm not a visual designer, so please excuse my drawing here, but that's more or like what I would see as a technical illustration of a component. So actually you have input to a component. You can put something into a component, so maybe some data or you can pass something into a component where the component does something with it. And a component can also have output, right? So it can notify his parent component in this holarchy, in this holistical system, about a change or about something, about any event. And inside of the component, we have a composition, right? A composition going. And this composition, there are multiple terms for this, but I like to use the word intrinsic and extrinsic composition. Because a component can demand on some composition, right? He can say, I want to be composed from the sidebar and the navigation and this component, right? But on the other hand, there is also an extrinsic composition. So if, for example, you have tabs or accordions or collapsibles, right? When you design a component like that, you don't put the content in there that will end up in your application when you design the tabs, right? So first you design the tabs, but then from the outside you're going to pass in the components that you want to have in the composition of these tabs. It's like an analogy would be a jar, right? An empty jar. An empty jar is nothing worth really until you put things in, right? And this is the extrinsic composition, right? So if you think about these components in this holarchy, they can actually then start communicating by touching these boundaries, right? So they can actually, the outer component can set an input of the middle component, and then the most inner component can also receive an input, and then the output is actually almost the same, right? So they can communicate upwards in this holarchy. So these are just a few properties of components. Of course, there are more. So components mostly live in the DOM hierarchy. I didn't see any implementation or framework that doesn't leverage the DOM as a hierarchy, as a primary hierarchy to establish the component tree. And it mostly reflects the visual hierarchy. So mostly, yeah, I mean, even the DOM today, if you use just like a web page and you have your DOM and your visual design, mostly it's reflecting the same hierarchy, right? The visual hierarchy is also the DOM hierarchy. There are some edge cases where you do crazy visual things, where this is kind of it's not necessary that it needs to be completely the same hierarchy, right? But mostly reflects. They communicate in the component tree, as we saw before, and they compose intrinsic and extrinsic. They can also hold state. And this is probably where people have a lot of opinion about state, right, in components, because this is where all these discussions happen in React, and dump components and stateless components and pure components and container components and all these kind of ideas about components. And I think it's just enough to say that they can hold state. I mean, a component can hold state. If you want to give it a state or not, that's your decision. So that's a simple example of a web component. Here we are actually using HTML imports of a profile component, of a user profile component, and then below we instantiate the component by using these custom elements. So we have a user profile custom element. And what you see here, the attribute name, what we are doing here is we just pass in an input to the component, right? So we pass a name input to the user profile component. And if we look at this implementation, you can see that the component, the self-contained component would look something like this. So this is version 1 web component, so version 1 custom elements and version 1 Shadow DOM. So here we are actually passing in, or we have a template where we display a name, or we want to display a name, so we have a placeholder. And in the code, we actually create a shadow DOM, and then we use the attribute that was set outside the name attribute and put this value of the name attribute inside of our paragraph with the class name, right? So that's the whole logic of this code snippet. And below, we register the custom element, right? So it's just a simple example to see how we can pass input to such a component, right? So one topic I would like to talk about, because it's really, really difficult with components, I think, is separation of concerns. Usually, if you can only use input for a component and it's a pure presentational component, there is not much difficulty in designing that, right? But as the application grows, and usually you start from the most fundamental components, which are usually presentational, right? So presentational. So you go up in this hierarchy, and then somewhere you need to get this data from, right? I mean, a component somewhere there needs to be data. Otherwise, these components cannot be filled with data. So this example is actually an Angular 2 component where we have kind of mixed concerns. So we mix the concern of data and presentation. In the code, we are fetching some data from a remote API. We get a name of a user, and we're going to put this into the state of our component and render it in the template. So this is not a really good approach. We can agree on that, right? Because if you want to reuse the user profile component, you cannot really do, because it's coupled to the data. So to solve this, and this is probably a pattern emerged from Redux, from the React community, what we can do is create so-called container components. And these container components, their only purpose is to wrap a presentational component and organize the data that this component needs. And then what you do is you just pass the data into the inputs of this presentational component. And like this, you can really extract all the data concerns out of your component, and your component is getting an additional name input, right? And now it's completely decoupled. So now you can use your user profile wherever you want, not only where it's necessary to do a remote API call, for example. So another topic, and this is really useful if you think about where do these container components occur? Where do they need to be? I mean, it would be silly if you have a container component around every presentational container component. That doesn't make any sense. So how can you identify these spots easily where there needs to be a container component? And for this, I think it's best if we compare this component tree or hierarchy with the semantic hierarchy, because there is also a semantic hierarchy in our DOM in this case, or in our component tree. So if we look at the semantics here, we have an application, and then we have a navigation on the left, and inside of the navigation we have navigation group components. So this is semantically probably right. So this path is semantically correct, if you ask me, right? We have an application, a navigation group, right? So there is not a big gap or anything like this. But if we now think about this one, user profile component, which is now part of this navigation component composition, okay? I mean, it could be solved differently, but in this case, it's done like this. And these cases you will face, right, in an application. So here we have actually a bigger gap. And if we think about this, I like to think about this of semantic boundaries, right? So we have kind of soft boundaries in the component hierarchy, between a few components. It can even be like 5 components. There can be soft semantic boundaries. They are all related, right? So we have like application navigation. So the application probably already knows about the data for the navigation. And in the inner 2 components, we have user profile, user image, right? Which is also a soft boundary. So they can really pass on the data. But then we have these hard boundaries inside of our application, right? Where we have, in this case, it's navigation user profile, right? And for this case, that's exactly a case where such a container component could or would need to be placed between, right? So that this container component could then deal with the data concern, because there is no data we can pass from the navigation to the user profile, right? So we need to have an intermediate container that is passing the data along in order to stay with presentational reusable components. So I like to think of this like this. So soft semantic boundaries tend to decrease scope depth, nothing else really. So you're going to zoom in the scope, right? You have a user profile, user image. It's kind of diving in the scope. And hard semantic boundaries tend to require different scope. So finally, I want to talk a little bit about sharing experience. So I think components is a pretty new field, right? We all need to learn. We all need to collect experience. So I would really be happy to have some discussions with you about how you use components. So maybe after the talk we can have some discussions. I think we need to share our experience more, right? And I have just a few experiences, 3 experiences I wanna show, or some results out of this experience. So I think it's really important that we collaboratively discover components with UX and visual designers. Because usually what we get is, as developers, we get a screen design. I mean, not from all the agencies and all the designers, but usually it's like this. And then it's not a system already, right? And then usually we need to draw the border again, right? So maybe it's also a communication issue sometimes, right? But we need to draw the border again. Okay, what is a component? What could be the subcomponents? But actually, if we do this process collaboratively while the project is growing, it's actually much nicer, because we can talk to the designers, we can talk to the UX and visual designers, we can agree on some components, and the developer could even also isolate semantic borders and identify where he would need to load data, for example. Another one is we can leverage existing frameworks. I mean, BEM and atomic design, they're both a really nice communication tool as well. I think they're even better communication tool than something else. Of course, they help us in a structural way as well, but I think if you think of components that are made of components that are made of components, that's already pretty good structure, right? I don't need to think in atoms, molecules, and organisms. But for communication, it's really, really good, right? Because we can talk about blocks and elements and atoms, and that fits really the purpose. So we can really reuse that for components. There is no reason why we cannot talk about blocks and elements and atoms and molecules. And then one last thing is we should really keep components as concise and small as possible, and use composition to introduce complexity. So even if I see a component with a template that has more than 100 lines, I would say it needs to be divided, it needs to be split. Even with 50 lines, I start to get suspicious, right? There must be a way to extract this, to simplify this, to keep or to make another iteration in this holarchy. Yeah, and finally, I just want to say that I think components is probably the game changer in web design and web development, because that's the first time we can build holistic systems with an architecture that is now being standardized, right? So we have a standard that is evolving into that direction. And I really think that if you look at electronics, for example, in electronics, it was the integrated circuit that was the revolution of electronics. Before that, everybody or every provider need to put all these electronic basic elements on one board. And now you have components, you have integrated circuits. And that was the revolution of electronics. So I really think this is a game changer. And it's more about the thinking, how we think about user interfaces, rather than a technology. Thank you.
Well, it's left us with a little bit of time for questions. And thank you so much for that talk. It got the design strategy side of my brain going, as well as looking at the development side of things. You can see how the way that you're looking at it would be a really great way of working within teams to create components consistently, and so that everyone knows what they're talking about as well. Nobody tweeted me, so I'm hoping some of you have questions. Hey, hands at the back.
Yeah, so sorry, one side note. I completed my book just a couple of months ago, and I have 3 copies here. It's Mastering Angular 2 Components, and the first 3 person who ask a question will receive a free book. So
Amazing.
But ask very simple questions, please.
Right. Okay, I'm running around to the back. Oh, you got it, Sasha?
Yeah. Hi.
Sorted.
Thanks for the talk. Do you have any solutions for how to also include CSS to the components?
Yes, I mean, there are tons of solutions, right? You could still go with global CSS and then use something like BEM, to modularize it or prefix it. But using Shadow DOM, for example, it's pretty easy because all your styles are scoped, right? But the standard alone, the example you saw, you could easily have a style element within this template. And then basically you instantiate the whole content of the template into Shadow DOM, so your styles will only live there. And as per the latest specification, or I don't know if it was always the case with HTML imports, but if you have a link rel in your template, you can actually scope, or the styles that you load from a different style sheet, they will be scoped to this Shadow DOM, right? So it's actually a nice way to modularize your design. And there are a lot of selectors already for making the connections.
We've got a question
yeah,
down
so
here.
You receive
as well.
a book before I forget it, or you can get it afterwards.
Just here in front of the pillar.
So,
Yes.
talking about styles, let's say you have these components where you want to share, let's say, the font family or something. What do you use to kind of expose from your component a way to set these across your whole site? If you want to change it, you don't want to change every component, I guess.
Yeah, that's true. I mean, you can leave. Yeah, that's a matter of how the shadow or what framework you are using, what technology you are using. But I think we're going to have a talk that is talking about that later on. Right? So I think I leave that open. No, I mean
I just wondered if you have like.
No, I mean I didn't
solve
really use an approach there yet. And to be honest with you, I mean mostly I'm still using global CSS for my components. I don't use scoped styling actually. I use a naming convention. I use BEM mostly, or we use BEM mostly, and then I scope these BEM prefixes to my components and elements. Yeah.
Yeah, I'm sorry, Max. There was one at the back first.
Yes, a book.
Hooray!
Thanks for the talk. And I'm also working with components. I started. And now I have a question about global parts of a system like authentication. Should I put this also in a component? And yeah, what's your opinion about it?
Yeah, that's a good question. I mean, you could argue that creating a container component is something similar, right? Because it's not a UI component, right?
Yes.
So why are we creating a container component, and why don't we create something like authentication in a service? And I think that's exactly a topic we need to get more experience. Because container components, for me, is really a hack. It's not an ideal solution. I would think of a system like this, that you have this holarchy or hierarchy of elements, and they get data more like aspect-oriented programming, right? So they get the data attached, right? Yeah. I don't know if that answers your question. Sorry, it leaves it open.
Yeah, Max at the front.
I gotta chime in here because in the React world, we've gotten something that's called Redux Saga, which is exactly what he meant, where you have a long-running transaction, a separate thread in your application that handles all the asynchronous stuff, all the data fetching, all data handling, and then you only render a hierarchy of components out. And I don't actually have a question. I just wanted to mention that my talk, The Future of CSS, is exactly about what he talked about. So you should come to that talk.
Yes, go to the talk. It's a good continuation, right, for this.
We have another question over here.
Hey, thanks for the talk. What would you say to a designer to accommodate atomic design? Like, I know this in many ways kind of goes against the keynote, the topic of the keynote, in that design should be more imaginative, and it should, you should build around the content, which I think would be hard to work with components in that way. So, like, what would you ask that almost like typography is an atom, and then maybe a button is, an element, something higher than that?
Yeah, I mean, it's a good question. Where do you start, right? I mean, I think when we are concerned about the hierarchy, the visual hierarchy, right? I think that's where components start from a design perspective, right? So in a design, you need to create some kind of a visual hierarchy, right? Otherwise, a user would be very confused if there is no visual hierarchy. So I think that hierarchy should be reflected with the component structure. And if you think of atomic design, I don't know if I understood the question right. So you think atomic design is limiting you in your creative workflow, or?
I guess I'm wondering, what would you ask of a designer when you say, hey, I'm going to be working with components in this hierarchy?
Mm-hmm.
How would you maybe ask them to present the design to you?
Well, to present the design to me as a client, or?
As someone who's building it out.
As somebody who's building it out. Yeah, so then I really have my recommendation, do it together. Because that's the most efficient way. Because then the developer can share his insights on how the component structure works, right, in an application, and a designer can put his insights where the visual boundaries would lie in these components, right? But, I mean, atomic design is pretty much made for designers, right? So I don't know, I'm not a designer, but I think it's really a good tool for a designer to, when he finalized his visuals, to break up his design into individual elements and intermediate stable forms, which are molecules and organisms, really. I don't know if that answers.
That's good.
Okay.
Any more questions? Aha. I heard a yes. Oh, right at the back over there. We're getting to run around.
Yeah, it's the problem with these fundamental talks, right? I didn't really talk about one technology or something, so it's kind of hard to answer the questions.
No, but it's very useful to
try
have
to-
an abstract oversight of these things. I think it's very important.
Yes, we are working also with components, and there's also a style guide sometimes where you have the components listed.
Yeah.
But many times you have components that aren't really visible. For example, a component to just get stuff done for all headline editing stuff. So how do you handle that? Have you like a platform where you share with the other guys what components are existent in this project or in this package, or what do you
So you
do?
talking about a software component that is not necessarily visible?
For example, or a method or a really small component who can have sometimes the same look as the other one, but it do this, different stuff.
Well,
For example, one time you have, it's very simple, but one time with a button and it's a file linked asset, another time it's a button who linked to a certain area of a page with scroll and jump and all this kind of stuff. So
and
it
what
looks
do you
the
want to
same, but
demonstrate? The look or the behavior?
No,
or?
it's more the question how you make the documentation of this stuff.
Okay.
So it gets really reusable, because sometimes you just forgot what you have already done.
Yeah, well, that's kind of a complex question, because it's also to do how you document, how you generate style guides, right? Do you have a static site generator that can, where you can build a system that visualize your components in different states, for example? But as far as a method to document this goes, I think BEM is really nice there, right? Because you have these states that you can use to illustrate modifiers, basically, where you can illustrate how the same component looks in different ways, right? If you think of that.
It's for me not about the looking, also about the function behind the component.
The behavior.
The behavior, not only about the CSS. Sometimes it's just the same because it has to look the same, but in the background it's the system.
I mean, if it behaves different and you want to document it, I guess there is no other way to provide examples of this behavior, right? On your style guide or wherever you want to demonstrate these behaviors, right? If it's the same component that can have different behaviors, I would demonstrate them by example on your style guide. Is that answering your question?
Not all,
maybe
but
we can have a discussion
Yeah,
around
maybe
that.
this is a discussion for the
it's
party.
probably, yeah.
One with a beer.
Yeah.
Got a question down here.
I have a question. How do you structure your projects to prevent like a small repetition of components which are nested inside of other components?
So you mean if you are going too granular?
Yeah, because then all the components flat structure, then you have like 1,000 components, and how do you have the
very
overview?
good point. Yeah, very good point. I mean, I didn't brought it in my presentation, but it would actually fit very well. I mean, you can also do too much of granularization, right? So if you have 1,000 components to implement a simple user interface view, you probably had built a little bit too much of components, right? So you can definitely go also in the other direction. And I mean, if you look at nature, for example, there are not always intermediate stable parts in nature, for example. Not every layer is stable. For example, if an organism dies, right, it falls apart into very, very fine granular pieces, which are probably some molecules directly. So the organs and everything of that, or the cells and everything of that organism also dissolves and cannot live anymore and dissolves into individual pieces. So I think if we create the intermediate components and think about the stability of these components, right? Is this component stable on its own, right? Does it reflect or fulfill some features? Can it be reused? All these factors that are important to think if it's stable. Then I think you are on a good granularity level.